Okay, we're now going on to topic 4.4 in Math 105. And this whole chapter deals with inequalities, but in this particular section we're talking about the absolute value in equations and also in inequalities. So I thought I'd give you a little review. We hadn't done this since chapter 1 of what absolute values are. And absolute value, the symbol for it is two vertical lines around some term or expression. And on a number line, what absolute value refers to is the distance that something is from zero. So if we said the absolute value of 4, its distance from 0 is 4 units. If we looked at the absolute value of negative 4, its distance from 0 is 4 units. So often in a short way we say the absolute value of anything is its positive value. And the letters that they're using in the beginning of this lesson, you're going to have some matching where you have the letter P, negative P, and 0, is that P stands for a positive integer. And a negative P, where this would have been positive, is now its opposite. And then the absolute value of 0, as we have here, is 0. So the absolute value of P is P. The absolute value of a negative P is also P. So a little review, and then we'll have some examples and give some more technique as we go on. Okay, this is a very typical example of an absolute value equation where you have an absolute value equals this. And my way of doing it, and again there may be other instructors that do it a little differently, I like to take away the absolute signs and just write it straight. X minus 1 equals 5. That would be one equation. Just take away the absolute signs. And then write what's in the absolute signs again. X minus 1 equals, now we said it could also equal its negative value, so it could have equaled a negative 5. So you get two equations out of it. One, just remove the absolute values, write it as it is. The other time, remove the absolute sign around your expression and just equal to its opposite. And then you solve your equations. So here we just transpose. We get x equals 6. Here we get x equals, this becomes a positive 1, so a negative 4. So that would be the solution to this equation, where this could have been a negative or could have been a positive, and that's what you're doing. Now, for this one, you have to be a little careful, because as you do it, and you change and make this a negative, you have to reverse this inequality sign. So the first way you can write it straight. X minus 1 is less than or equal to 5. Now when you write it again, or x minus 1, change the direction of that sign. It's going to be greater than or equal to a negative 5. All right, so that's the key when you are setting up your absolute values where they are inequalities. And then in solving them, just straightforward, x transpose the negative 1 is less than or equal to 6, or x transpose that, and that's going to be greater than or equal to adding a positive 1 to that, a negative 4. So those are your two answers. Now, they even sometimes graph these because that's what we did in our previous lesson. So if you were going to graph that or put it in set builder notation, you'd say that x is here in the middle and negative 4 is over here, and then your x is in the middle and it's less than or equal to 6. So we've done that before. And then set builder, put a line there, x is such. And then you could graph that. You could also give its interval notation if they wanted. But here they just want the solutions. X is less than or equal to 6. X is greater or equal to negative 4. In number 8, there's not a lot of work. It's just that x will be equal to 4.3 or a negative 4.3. And then in the case of 0, it's t equals 0. And in number 10, we get to our strategy. Again, other instructors may do it a little differently, but I like to just take away the absolute signs. X minus 7 equals 10, or x minus 7 equals a negative 10. So as you solve, you just transpose x equals 17, or x equals a negative 3. So again, the work not too difficult, but you need to know the rules and have a strategy for doing what you do. A key here for this one, when you have inequalities, is that when you make this a negative, you have to reverse the sign. Number 11, you might put a little star by number 11, because that's sort of a trick question. Here they're saying the absolute value of something is equal to a negative. And by definition, the absolute value of something has to be positive. So when you see something like this, the absolute value of something is equal to a negative something, there's no solution for that. And what we put is the empty set symbol. Now, for number 12, again, we're going to set these up, and what I'm going to do, because I'll run out of room, is put it here a little bit. So it's 3x minus 7 equals 4, or 3x minus 7 equals a negative 4. So again, we're using that technique of just taking away the absolute signs and writing it in its positive form, and then writing it as a negative. So we solve it by transposing 3x equals 11. Divide both sides by 3. X equals 11/3. And this one, as we transpose, we get a positive 7, so this is going to be 3x equals 3. Divide both sides by 3, and I read out of room, x equals 1. So our answer set is 1 11/3. Okay, I'll leave it there. Now, this one, again, is introducing a new rule where you want to isolate the absolute value on one side. So we need to get rid of our negative 7, and then this then becomes a 16 over there, adding 7 to both sides, and then we write the equation twice, 5x equals 16, or 5x equals a negative 16. So we've taken the negative 7, brought it over as a positive 7, that gave me a 16, and I'm using that for both of them. Take away the absolute signs, and these are our equations. Then we just divide both sides by 5. X equals 16/5. And here, divide both sides by 5. X equals a negative 16/5. And that would be our answer set. Now, for this one, in solving it, basically we could rewrite it this way. Take away the absolute signs, equal 11. Take away the absolute signs equals a negative 11. So, and then we're going to multiply both sides by 2. So once again, take away this, and that's a positive. Take this away, that's a negative. Then we're going to multiply both sides by 2. So on this side, the 2's cancel out, and let's do that. And then we're going to multiply this by 2. Remember, it's going to be an 11 and also a negative 11. So again, I didn't give myself too much room here. So this then becomes, the 2's cancel out, and we get 3 minus 5t equals 22. And then again, this will be a negative 22, so I'm going to get or 3 minus 5t equals a negative 22. So to get rid of the fraction, in a sense we're multiplying both sides by 2, that cancels out on this side. So I just get 3 minus 5t equals 22, or 3 minus 5t equals a negative 22. And then from there we solve our equation. I'm going to subtract 3 from both sides. That gives me an 18 here, 19 I should say. Divide both sides by a negative 5. So I get t equals a negative 19/5. And then here I'm going to subtract 3 from both sides. This gives me a negative 25 there. Negative 5t equals that. Divide both sides by a negative 5. Here I get t equals 5. So my answer set for number 14 is a negative 19/5 and a positive 5. Now this last one is just introducing again the idea of function. And all they're asking is that this equals that. So we can write it here. 2x plus 9 equals 15. This equals that. Or 2x plus 9 equals a negative 15. I'm going to just check that we're still in here. Yep. So here we're going to subtract 9 from both sides. And this gives us a 6. And it gives us x equals 3. And here we're going to subtract 9 from both sides. This will give us a negative 25. How about a negative 24, I should say. And then divide both sides by 2. And I get x equals a negative 12. And that's good. Okay, so as we move on, we see absolute value, not too big a deal. It's just that basically, whatever you have in the absolute sign, that's going to equal something. But the absolute sign can also equal its opposite. And through practice. As we look at number 16, and then there are 17, 18, and a few more examples that are like this, I'm only going to do one to show you how it's done. So here we have the absolute value of something equals the absolute value of something. But we know in our technique that when we take the absolute value of something, it could also be a negative. So we're taking away our absolute signs, and we set our first equation up just like that. Then when we set up our second equation, we take away the absolute sign, but we need to put the opposite of this. And that's what I've done here by putting a negative in front of what was in the absolute sign there. Okay? So that's the strategy behind it. That's what I want to be sure you understand and are using. So here, we're going to subtract an x from both sides. Here the x disappears. We get an x left there. Here we're going to subtract a 1 from both sides. And there's one of our answers. And then over here, the first thing we need to do is to take away the parenthesis and change each of these signs. So this x was positive, now it becomes negative. This negative 6 was negative, now it becomes positive. And we don't have a parenthesis anymore. So that was a rule we had done earlier. And now we solve that. So we're going to add an x to both sides. This gives me my 3. We're going to subtract a 1 from both sides. That gives me my 5. And then I'm going to divide both sides by 3. And that gives us our x equals 5/3. So remember, as we write these, we usually write it in brackets. And I believe in MATLAB they are providing you with the brackets. All you have to do is separate your answers. Okay, so there are a couple like this, and that's how you do it. Now in 20 and 21, we're asked to graph these. So let's solve them first. Here we're going to say that x is greater or equal to 3, or Now we have to reverse that sign, is less than or equal to negative 3. So again, you're looking for a strategy to do this. So now there's our graph. The numbers we're looking for are a negative 3 and a positive 3. And here we're saying that x is greater or equal to 3. So at the 3, we're going to include 3 by putting a bracket there and then extending our line out this way. And then here we're saying that x is less than or equal to a negative 3. So we put a line, again a bracket, and a line extending out this way. So as you recall, this is a disjunction from an earlier lesson, and that's the graph. And if you wanted to write this in set builder notation, it would look like this. X is such that actually you would write this one here first. X is less than or equal to negative 3, or x is greater or equal to 3. And you recall, if you were doing interval notation, this would be coming from negative infinity up to a negative 3 with a bracket, and then in union with this other 3 that starts there as a positive 3 to positive infinity. Okay. Now this other one, because of the nature of the first sign where this is greater, this is less. Got to be careful about this. So this is going to be x is less than 15, and x is greater than negative 15. You had to reverse that sign, remember. So there is a positive, we have to make it a negative. Now in graphing this, our numbers are a negative 15 and a positive 15. And what are we saying? Well, we're saying that x is less than 15. So we're going to use a parenthesis facing this way. And this one is x is greater than negative 15, would be a parenthesis facing that way, and then filling in between the two. So here we have a conjunction, and in writing this in set builder notation, we would say x is such that negative 15 is less than x, x is less than 15. And in interval notation, it would just be negative 15 to 15. And keep in mind, when we have a parenthesis, that indicates that the number we're featuring here is not included in the set. When we have a bracket, it indicates the number is included in the set. Now there are some other examples in which you have to solve, but this is your basic technique. Maybe we'll do one of those. Okay, I think we'll use 23 as an example for all of this type. Now again, the technique is to isolate the absolute value. So this is going to become the absolute value of x minus 3. We're going to subtract 8 from both sides. And then this will give us greater than or equal to 6. So again, in isolating the variable, we just transpose the positive 8 to this side, it becomes a negative 8, and it disappears from there, and it becomes this. Then we're using our same technique for solving these inequalities. We write it twice. X minus 3 is greater than or equal to 6, or X minus 3 is less than, we have to reverse the sign, or equal to a negative 6. So there's our two equations, or inequalities. We transpose this, and this becomes X is greater or equal to 9. Bringing the negative 3 over becomes a positive. And then this is going to be X is less than or equal to a negative 3. Okay? Now, notice that whenever you have a greater than symbol here, you're going to have a disjunction. So let's draw the graph. And we're interested in a negative 3 and a 9. And for this one, it's greater than or equal to, we're going to use a bracket. And for this one, we're also going to use a bracket, but facing left. And again, a disjunction. And the interval notation of this would be from negative infinity to a negative 3, bracket, union, bracket 9, to positive infinity. And set builder notation, we did one like that already. If it doesn't call for it here, they just want the graph. Okay, well, this will wind this up. Again, I don't think it's too difficult as long as you know what's going on here.